afternoon, boys and girls. We are here today to continue our lesson from last week. Remember I gave you some homework last week? Yes, I know you think I forget about them. So we are going to get the answers for those homework, and then we are going to find LCM. We are going to use different methods of finding LCM. Then we are going to arrange our fraction using LCM. Last class, we arranged using multiples or finding equivalent. But this class, we are going to arrange using LCM. So from last week, this was number one question you had to do. And you had to do it either ascending or descending order. You choose which way you want. So here are my answers. So if you're doing descending order, this will be your answer. So if you have this as your answer, you are quite correct. If you do ascending order, and remember ascending means from smallest to biggest. We are ascending, we are going above. This will be your answer. Number two, this was your second question from your homework, right? And we had to do the same thing, either ascending order or descending order. Here are my answers. Right. If you notice, this has two answers. That is because two of our fractions were the same value. And we can put them any places. So you notice I have 1/2, then 5/10. And at the next one I have 5/10 or 1/2. It doesn't matter the order once they come right after each other. So this is from smallest to largest. And it will be the same with the descending order. We can switch 1/2 and 5/10 because they have the same value. So it doesn't matter which way you put those two, once they are right after each other. Did you get all correct? Very good. So today, we are going to learn to find LCM. Last week, you can say we find LCM when we were generating multiples. But we are going to find LCM using two different methods today. So we are going to use where we'll find our LCM using, I normally call it division, some people call it tables. Hi, Randon. So I am going to use LCM first using division. And some people call it the table method. So here are my numbers. So these are my three numbers I need to find the LCM for. 8, 4, and 12. And when I say the table method or the division method, we are going to make a table. So we'll have one digit in each column. So we have three numbers, so we have three columns. So I'll put my 8, 4, and 12. Now in doing the table method, what we are looking for, we are going to look for especially prime numbers that can divide each of these digits without a remainder. If when we think we are going to divide it and there is a remainder, we do not touch it. We just bring it down to the next level until we can find something that can divide it without a remainder. You know what I mean when I say prime numbers? Yes, prime numbers have only two factors. And we know the smallest prime number we have is 2. So when we look at these numbers, we can see they are all multiples of 2. So we can divide them by 2. So we start dividing, so we divide by 2. 8 divided by 2, our answer comes below here, 4. 4 divided by 2, 2. And 12 divided by 2, 6. And one more thing. What we are hoping for is that at the end of our column, we will end up with numeral 1. If we are not at numeral 1, it means that column is not finished. Each column must have numeral 1 in order for it to be finished. Look at our numbers, they are still multiples of 2. So we can divide by 2 again. Make a line, so we separate our 2's. 4 divided by 2, 2. 2 divided by 2, 1. What can you tell about that column? Yes, that column is finished. 6 divided by 2, 3. So we have 2 columns we have to still deal with because we are not finished. Okay, we notice this is a multiple of 2. This column is finished, and this is 3. So I say, if we cannot divide, we just bring it down. So let's divide by 2 again. 2 divided by 2, 1. Yes, this column is finished. And this is already finished, so we just bring back our 1. 3 cannot divide by 2 without a remainder. So we'll just put back our 3 there. We have to find something that can divide this without a remainder. When you look at this, tell me a prime number we can divide 3 by that we would not have a remainder. Excellent, 3. So we are going to divide by 3. This column is finished, so we just bring our 1 down. This is finished. Bring it down, so we'll keep the space. And now we can say 3 divided by 3. Right. So all 3 columns are finished. So now, in order to get our LCM, what we need to do, we are going to multiply all these prime numbers we have at the end here. So the numbers we have at the end, 2 times 2 times 2 times 3. So we are going to multiply these. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. So what is my LCM? Yes, so my LCM is 24. And when I say LCM, what do I mean? Yes, lowest common multiple. But normally we just use the abbreviation LCM. So anytime you hear LCM, we are talking about lowest common multiple. So this is one way we can find our LCM, by using table form, or we say we use division. So this is one way. I'm going to give one other method, because last week we did multiples, where we generate multiples. Now we do tables, and I'm going to do one other method. Now that you know what are prime numbers, I am sure you know what is prime factorization. You know what it is? Yes, okay, yes. The factor tree, exactly. So we are going to make factor tree for each of these. We are going to use these same numbers. Let's see if we'll get the same answer when we do it any method. So we are going to use factor tree to find our prime factorization for each of these. So here I have my 8, 4, and 12. Yes, I'm going to make my factor tree. So on my factor tree, I normally say you branch it out. You always go in branches of 2. So here I have 2 branches. And I'm going to find 2 factors of 8, which is 2 numbers that can be divided by, that can be multiplied, and you get 8 as your answer. So tell me, very good. 2 and 4. So 2 times 4 is 8. And there is one more thing I want you to pay attention to. Whenever we find those factors, if any of the factor is a prime number, you circle that number. Do we have any prime number there? Yes. So we circle this prime number because our aim is to get all prime numbers. So 4 is not a prime number. It is still a composite number, so we are going to branch it out as well. So we'll have 2 branches under 4. And we are going to find 2 factors of 4. Excellent. 2 times 2. So this will be 2 times 2. Circle both of them. Why do I circle both of them? Yes, because they are all prime numbers. And I say to circle your prime numbers. Yes, Kelly, 2. So, this is finished because all my numbers are circled. So I can find the prime factorization for 8 will be multiply all the digits that are circled. So I have 2 times 2 times 2. And when I multiply that, I should get 8. So I'm finished doing my tree, my factor tree, or having my prime factorization for 8. Now I'm going to find the prime factorization for 4. Yes, I have my branch, and that is easy because we just did 4 here. So it's easy for us to get the 2 factors. When we had our branch here, we had 2 times 2. So we'll use back these same 2. 2 times 2, and yes, they are prime numbers, so we circle these as well. And our prime factorization for 4 will be 2 times 2 equal 4. So now we are going to do 12. Yes, so I need to put my branch for 12. So I have 2 branches. So we can do any 2 factors. Yes, you said 2 times 8. Yes, you said 3 times 4. We can use any of them. Well, let's use 3 times 4. So we are going to use 3 times 4. Are you sure? Yes, he said to circle 3 because 3 is a prime number. So here is my 3, I circle it, so I don't have to branch that anymore. I rest it aside until I'm ready for it. But 4 is not prime, so I branch it. So I have my 2 branches. And we know what are the factors of 4, what are the prime numbers that will give us 4. So we have 2 times 2, and yes, we branch these now. So my prime factorization for 12 will be 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. So here, we should get these back. So we are going to use these prime factorization to find our LCM. And I like to say, arrange them. So you get what is common under each other. So let's start with 8. Let's start with 8. So my prime factorization for 8, we have 2 times 2 times 2. So we have these 3. For 4, we have 2 times 2. And you notice, I put my 2 on the 2. So you try and get them organized so you can get what is common among them. And for 12, I will have 2 times 2 times 3 by itself. So we are going to look for what is common. So we notice we have 2 here. So we will only need that 2 one time. So we are just using the common ones one time. And we have 2 here. So what it is saying, in order for us to find our LCM here, we are going to multiply our common by our uncommon. So we are going to multiply what is common and what is not common. So 2 is common here, but it's not common with the others here. And let me let you know, even though we have 3 numbers, if I had another 2 here, it would have been common, because it's at least in 2 of them. But if it's only just 1, we say that it's uncommon. So here, these are what I have common. So this will be my 2. This is uncommon times, what is common here? 2. So we just write that 2 one time. Times 2 is also common here, and we write that 2 one time. And here we have 3, which is uncommon, and we write that 3. And now we can multiply. What does this look like, what we did before? Yes, it looked just like this. So we are ending up with the same answer. So we are having 24 as our LCM. So if we have 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. So it doesn't matter which way you do it. If you want to do the table way, or if you want to do the prime factorization way, you will still end up with the same LCM. You think you get that? Let's try one more example. So yes, give me some numbers you want. Okay? 5, 15, 10. Let's see if you can work this. Which method you want us to work first? Okay, so the prime factorization first. So let's work it prime factorization. And let me work it right under here. So we'll have our numbers 5, 15, 10. And we are going to find our prime factorization. How do we find that? Yes, we look for 2 factors. When we multiply them, we will get what we are dealing with. But look at 5 here. What kind of number is 5? It's a prime number. So what would you say? Yes, I will just circle it one time because I am looking for prime numbers. I don't need to branch this because this is already prime, so we don't have to do anything to this. So let's look at 15. So I branch 15. Very good. 3 times 5. Excellent. So I circle both of them because both of them are prime. Remember, we are looking for the prime numbers. Then I go to 10. I branch 10 and I will have 2 times 5. Same thing here. They are prime numbers, so we just circle these. Now we need to arrange them so we can see what is common and what is not common. So for 5, we just have 5 all by itself. And for 15, we will have 3 times 5. And for 10, we would have 2 times 5. Are you with me? Yes. Very good. So I circle what is common. So I'll circle my, and you realize 5 is the only thing we have common. So we need to multiply our uncommon by our common. So what are we going to multiply? Yes, so we are going to multiply 2 times 3 times 5. We put in these in bracket in a circle because we only want to use one of them. That's why we're looking for the common. So we only multiplying the common digit once. So now we can find our LCM. 2 times 3. 6. 6 times 5. Yes. So my answer here is 30. Very good. So let's do it. You think we have to do it the table way? Okay, let's do it the table way. So in my table, I should have 3 columns. 1 digit each per column. So I have 5, 15, 10. Thank you very much, Nat. So we have 5, 15, 10. So we are going to divide by, what is common there? Yes, we can see we can divide by 5. And is 5 a prime number? Yes, so we can use 5. 5 divided by 5, 1. So we know what? Yes, that column is finished because we end up with a 1. 15 divided by 5, 3. And then 10 divided by 5, 2. So we realize we still have 2 columns to work on. So let's go. Let's look for something that is common. Nothing is common, so we'll have to do them separate. So let's say, divide by 2. This is already 1, so we just return the 1 there. 3, 2 cannot divide 3, so we bring back our 3. And then we can say 2 divided by 2, 1. So those 2 columns are finished. Now we have our last column, and it is easy. What can we divide by? Yes, 3 is the only thing that can divide 3 that will give us 1. So we will use 3. 1, come back, 3 divided by 3, 1, 1. So because we have all 1s, we know we are finished. And we find our LCM by multiplying what we have at the end here. So we'll have 5 times 2 times 3. 5 times 2, 10. 10 times 3, 30. So our LCM would be 30. And in this case, it doesn't matter. You don't have to arrange them in order. Once you multiply, the order does not matter. So here we have our LCM as 30. Now I want to see if you were following me. So I'm going to give you one example to do during our break time, and we'll be right back to use it. Okay, I've seen some of your answers, and some people probably made some mistakes. I realize I have 2 correct answers so far, which was Monty Chambers, and I can't remember the other name. But yes, if you have 36, that is the correct LCM. 36 is the correct LCM. Very good, Lucy. 36 and not 20 and not 80. Use these fractions, and we are going to arrange them in order. But before you can arrange them in order, you must find the LCM. So you must find the LCM in order to arrange them in order. So let's look at my numbers. And I have 4 this time. Principle doesn't change. It doesn't matter how many you have. Same thing. So we are going to work it using the table. So let's use the table. So I need, how many columns do I need now? Yes, I would need 4 columns because I have 4 numbers. I have 4 fractions. So I need 4 columns. So I'll put 1 denominator each in the column. Remember, we are finding the LCM, which would, in this case, we will call it LCD, because these are now denominators. So we are going to find our LCD, which is the same as your LCM. So we are going to have 1 denominator there, 8 there, 2 there, and 4. So we are going to find a number, and as I say, preferably a prime number that can divide each of these without a remainder. So we are going to use, yes, 2. So we are going to divide by 2. So we can say 6 divided by 2, 3. 8 divided by 2, 4. 2 divided by 2, yes, and that column is finished because we have numeral 1 here. And 4 divided by 2, 2. So we still have 3 columns to work with. So we draw our line. We could call it a vinculum, just like what we did in the fraction. We can also divide by 2. So we divide by 2 here. 3, we cannot get whole numbers out of 3. We cannot get groups of 2 out of 3 without a remainder. So we'll just kindly bring our 3 back down there. 4 divided by 2, yes, that can work, and we'll get 2. Bring 1 and 2 divided by 2. So 2 columns are finished. So we have 2 more columns to go. Let's use 2 again. And we know this cannot be divided by 2 without a remainder. So all we have to do is bring it back here because we are looking for numbers that can divide them without a remainder. 2 divided by 2, 1. So 3 columns are finished. So we have our last column to go. Yes, so we divide by 3. So 3 divided by 3, and all these were finished before. And to get our LCM, take all the prime numbers that we have at the side that we divide by, and we are going to multiply them to find our LCM. So we will have 2 times 2 times 2 times 3. And try not to make any mistakes. I have 1, 2, 3 2s. So you make sure you have your 3 2s as well. And we have 1, 3. So, yes, Larissa, that is correct. 2 times 2, 4. 4 times 2, 8. And 8 times 3, 24. Thumbs up to Larissa. So our LCM is 24. And that is one part of it. Yes, Amanda Bentek, you are so right. So we have our LCM, and now we need to use this 24 to arrange these. Now, we can do it 2 ways. Now I have my LCM, I can do it 2 ways. I'm going to show you 2 ways we can do it. So this is 6. Now, my LCM is 24. And when we say LCM, that is our new denominator. That will be our new denominator. So we are going to make all these denominators into 24. So I ask myself, here is 6. How do I get 6 to become 24? Tell me. Yes, so we multiply 6 by 4 and we get 24. And anything we do to our denominator, we must do it to our numerator so that we do not change the value of our fraction. So we'll have to multiply 2 by 4 as well. So our new fraction for this fraction would be 2 times 4, 8, and we already know 6 times 4 would be 24. So that is our new denominator. This is our new fraction for this. Value doesn't change, no matter the digits you have. 8 here, and we want 8 to be 24. How can I get 8 to be 24? Yes, so I multiply by 3. And whatever I do to the denominator, I must do it to the numerator. So multiply by 3 as well. So my new fraction here will be 3 times 3, 9. 8 times 3, we should know that, 24. Very good. Now our next fraction is 1/2. My denominator here is 2. How can we get 2 to become 24? Very good. 2 times 12. Times 12, and yes, 1 times 12. So 1 times 12 would be 12, and 2 times 12 would be 24. And the last fraction, 4. We want 4 to become? So, yes, we multiply by 6. And you could see the connection here. If I multiply 6 by 4 to get 24, now when I get to 4, I must multiply it by 6. And I have to multiply here by 6 as well. 6 times 1, 6. 6 times 4. Can you arrange these now? Can you arrange these in ascending order? Which is the smallest? Yes, so we'll write, this is the smallest, but we are not going to write this because the teacher did not give you this fraction to arrange. This is equivalent to this. So when we find this is the smallest, we look for the fraction that it is connected with, the one that you were given. So our smallest would be 1/4. So in our answer, we'll have 1/4. Yes, so 8/24 is same as 2/6. Very good. Now this is 9 because 9 is less than 12. So we'll have 9/24, which is equal to 3/8. And the biggest would be 1/2. Think you get that? So that is one way. So we can use it like this. We can do it where we have 24 as our big denominator. So we are going to do it that way now. So we have 2/6, 3/8, 1/2, and 1/4. And we say our LCM is 24. Okay, very good, Larissa. You're well following. Very good. So our LCM is 24. So I'm going to make one big vinculum. So we have this one big vinculum, and our LCM, which is my new denominator, would be 24. So we are going to find out how we are going to have this. So this is how we are going to do this. We are going to see how many times we can get our small denominator or our original denominator out of our new denominator. We can say we are going to divide the new denominator by the old denominator, because our new denominator is now our LCM. And when we find how many times we are going to multiply it by the numerator. Think you follow? Right, so let's go. 24 divided by 6. Yes. So we get 6, 12, 18, 24. Very good. 4. And we say when we get the answer here, we have to multiply the numerator by it. 4 times 2, 8. So this is saying this is 824. Did we get 824 over here? Yes. So it's the same thing. We do the same here. 24 divided by 8. How many times can I get 8 out of 24? 3. And then we are going to, what we get, whatever answer we get, we multiply the numerator by it. 3 times 3 would be 9. 24 divided by 2. 12. 12 times 1, 12. And the same thing we do here. 24 divided by 4. 6. 6 times 1, 6. So what this is saying, this fraction is 824. This fraction, because the numbers are right under them, is 924. Remember, 24 is our LCM. So everything will have 24 as its denominator. This fraction is 12 24th. And this fraction is 6 24th. So we can arrange them. You notice 6 is the smallest, then 8, then 9, then 12. And if we are going in descending order, tell me what should I have first? Yes, so I will have this one, which is 1/2, because 12 is the biggest here. Then I will have 3 8, then I will have 2 6, and then I will have 1/6. So we can arrange it using LCM either this way or using this one big LCM, this one big new denominator, and we'll end up with the same answer. So you know I always love to give homework. So for your homework, you're going to do this one for our next time. You're going to do these two. Find the LCM for these two. And you're going to arrange this fraction in order using the LCM. So work on these until we meet again next time.